Section 13.8, Solution Stoichiometry. We looked at stoichiometry a couple of times now, once using masses and once using gases. And now we're going to look at it using solutions. Many reactions occur in solution, and so it can be very convenient to specify the amount of reactant or product based on its volume and concentration. So from the volume and concentration, the molarity, we can calculate the moles of reactants or products, and that's what we need to do stoichiometry. Remember, the general path for stoichiometry was grams to moles to moles to grams. The part that's always the same is the moles to moles in the middle. And then on either end, you can have a variation. You could go to liters of some concentration. You could start out that way with volume and concentration. And so that's what we're going to do in this section. We're going to look at using solution concentrations with the stoichiometry. So typically this will involve a volume because that's what we can measure, a volume at the beginning and or at the end instead of a mass. Let's do an example. How much 0.125 molar sodium hydroxide solution do we need to completely neutralize 0.225 liters of 0.175 molar sulfuric acid solution, H2SO4? Again, a good approach is to use this balanced chemical equation to help us organize all these numbers. So this 0.125 capital M refers to the sodium hydroxide. So I'm going to write that under the sodium hydroxide, 0.125. And instead of writing capital M, which is an abbreviation, I'm going to write moles per liter, because that helps me to see what that unit really means. 0.225 liters and 0.175 molar refer to the sulfuric acid, and so I'm going to write those under sulfuric acid, 0.225 liters and 0.175, again writing that capital M as moles per liter. What question are they asking us? What do we need to find? First two words, right? How much? How much sodium hydroxide? They don't specifically come out and say volume, but how do we generally measure liquids? By volume, right? They're wanting to know the volume. So question mark, liter. What volume of that solution? We have two numbers pertaining to the sulfuric acid. This one has the unit liter, and this one has the unit moles per liter. Per units usually imply that this is a conversion factor. It can be hard to know what of these numbers should I start with. Where do I begin? Sodium hydroxide is the one we're trying to find something out about, so we don't want to start with that one. We want to start with the other one. And then looking at the units, we're going to start with liters. And so our path here is going to be liters to moles, and then back to liters again. Does that make sense? You guys awake? Your eyes are open, but I don't know if anybody's home. Somebody home? Okay. So I'm going to start with this 0.225 liters of H2SO4, and I'm going to go from liters to moles of H2SO4, to moles of sodium hydroxide, to liters of sodium hydroxide. I don't seem to be able to write small anymore. It's bad drawing on the iPad, Dave. We set up our path, liters to moles to moles to liters, and these become the units in the numerators of our fractions, our conversion factors. And then we want liters of H2SO4 down here, because we want those units to cancel out. It's dimensional analysis again. There's a reason why I forced this on you, because it's really useful. And then over here we want moles of sodium hydroxide. Sorry for my mess. It's terrible. Put all the units in, then go looking for numbers. Here I need a relationship between moles and liters of sulfuric acid, H2SO4. That's this concentration right here. 0.175 is with moles. Just take this line and extend it all the way across. So in my equation down here, that goes in the numerator, 0.175 moles per liter. Where do we get the numbers for the middle term, moles to moles? From the balanced chemical equation. There is no coefficient in front of H2SO4. There's a coefficient of 2 in front of sodium hydroxide. So we write those same numbers down here. Now you don't have to write the 1, but if you feel better, go ahead and write a 1. Then we need a concentration over here. We've got liters on top and moles on the bottom for sodium hydroxide. That's this number. Again, think of this line as going all the way across. 0.125 goes with moles. I made a horrible mess of this. Then we just multiply and divide our way across. 0.225 times 0.175 times 2 divided by 0.125 equals, the calculator is telling me 0.63. How many significant figures should that number have? It should have 3. This volume had 3, this concentration had 3, this concentration had 3. The coefficients in the equation are exact and they don't count. So what do I do to get 3? I need to add a 0 at the end. The calculator doesn't understand that, but we need to be smarter than the calculator. And then the unit is liters. And so there's my answer. It will take 0.630 liters of sodium hydroxide to neutralize the H2SO4. Any questions?